Welcome back to G Fun Facts Online, your go-to source for the most amazing tidbits from the world of science and technology. Today, we're diving deep, and I mean that literally, into a world where robots aren't just confined to land or water. Imagine a machine that can roll across a beach, then plunge into the waves and swim away, or even crawl out of a river and start exploring the forest. We're talking about amphibious robots. These incredible machines are pushing the boundaries of what's possible, and trust me, you're going to want to hear all about them. So what exactly are amphibious robots? Well, just like their animal namesakes, think frogs or salamanders, these robots are master navigators of both terrestrial and aquatic environments. That's right, they're designed to operate on land and in water. This versatility isn't just a cool party trick. It makes them incredibly valuable. Picture this: a disaster zone where rescue teams need to search flooded areas and then move onto unstable ground. Amphibious robots to the rescue. They're also becoming crucial for things like reconnaissance missions in tricky coastal areas, surveying underwater landscapes and then mapping the shoreline, or even monitoring our precious ecosystems in rivers, lakes, and oceans. They can go where humans can't, or where it's too dangerous for us to venture. Now, designing a robot that's a champion on both land and sea is no easy feat. It's a huge engineering puzzle. Think about it. What makes a car good on the road is very different from what makes a boat glide through water. Engineers have to perform this incredible balancing act. Features that make a robot sturdy and able to carry loads on land often make it clumsy and slow in the water. And then there's the transition zone, that tricky area where land meets water, like a beach or a riverbank. This littoral zone, as it's called, is full of turbulence, shifting sand or mud, and all sorts of obstacles. It's a robot's nightmare. So, what are the secret ingredients for a successful amphibious robot? First off, waterproofing is absolutely essential. You don't want those delicate electronics getting a surprise bath. Then there's buoyancy control. The robot needs to float when it should and submerge when required. And of course, propulsion. How does it move? We'll get to that in a moment because it's fascinating. Plus, they need sophisticated sensors to see and navigate in both air and water. And they must be built from materials that are tough, don't corrode, and can handle the stress of both worlds. All right, let's talk about how these marvels of engineering actually get around. There's no one-size-fits-all solution, which makes it even more interesting. First up, we have wheeled robots. Sometimes, they use the same wheels for both land and water. Simple, right? But this can mean they're a bit slow in the water because of drag. So, clever designers are coming up with wheels that have paddles or can even transform into propellers. These guys are usually pretty zippy on smooth surfaces. Then there are legged robots. These are often inspired by nature's crawlers. Think salamanders, cockroaches, or even crabs. Legs are fantastic for tackling uneven terrain and obstacles. In the water, they might use their legs for paddling or even walking along the seabed. They might not be the fastest, but their adaptability is incredible. And get this for a cool bit of tech. Some new legged robots use something called implicit control. Instead of constantly trying to figure out the environment, the robot's body and how it interacts with the world are part of the control system. This means smoother transitions between surfaces without a hiccup. Next, imagine a robot that moves like a snake or an eel. These are undulating robots. They use body waves to propel themselves through water and even across land. Super flexible and great for navigating tight, complex spaces, though controlling all those segments can be a bit of a brain teaser for the engineers. Many amphibious robots are actually hybrid mechanisms, combining different ways to move. Some have totally separate systems, say wheels for land and propellers for water. This means each system can be super efficient in its own domain, but it does make the robot more complex. Others use united propulsive mechanisms, where the same parts do double duty. Think of special wheels that also act as paddles, or even limbs that can transform from flippers for swimming into legs for walking. And if that's not futuristic enough for you, there are even soft robots emerging. These flexible wonders offer amazing adaptability, especially in unpredictable environments. Some can even achieve multimodal locomotion, like jumping on both land and water. How cool is that? Where do engineers get all these brilliant ideas? Well, often they look to the ultimate expert in amphibious design, Mother Nature. Animals have been mastering land and water movement for millions of years, so it makes sense to learn from them. Take salamander-inspired robots. These often have flexible bodies and articulated limbs, mimicking how real salamanders walk and swim. Some even use something called central pattern generators, or CPGs. These are like tiny neural circuits that automatically generate rhythmic movements, just like in animals. Then there are turtle-inspired robots. Imagine robots with limbs that can actually morph, changing their shape and stiffness. They can go from a sleek, streamlined flipper perfect for swimming to a robust leg for stomping around on land. That's some next-level adaptation. And it doesn't stop there. We have fish-inspired robots that use fish-like body wiggles for swimming and might have wheels or legs for land travel. Some designers are even taking a page from Legos, creating modular robots. These can be taken apart, have parts replaced, or even combine different modules, like a floating robot that can attach to a crawler chassis for land movement. Talk about versatility. One of the make-or-break moments for an amphibious robot is that transition, smoothly moving from land to water, or vice versa. Remember that challenging littoral zone we talked about? Sandy beaches, muddy banks, rocky shores. These are tough. The robots need powerful propulsion and super adaptable maneuvering to conquer these obstacles. So how do they do it? Some designs feature clever hybrid wheel propeller mechanisms. These can provide forward thrust in the water, and then the propulsive bits reorient themselves to act as wheels on land. We also see those amazing transformable limbs we mentioned, changing shape or stiffness to be perfect for either swimming or walking. And some use track-based systems, like mini tanks, but with added fins for underwater movement. Sometimes, both the tracks and fins can even operate at the same time to avoid any awkward switching delays. The world of amphibious robotics is moving incredibly fast, and the future looks absolutely fascinating. So what's on the horizon? Scientists and engineers are constantly working on improving efficiency and speed, making these robots better, faster, and stronger in both environments. There's a huge push for greater adaptability. The goal is to create robots that can handle truly unstructured and unpredictable terrains, especially that tricky littoral zone, without breaking a sweat. We're also seeing incredibly sophisticated control systems. Think advanced algorithms, perhaps even based on artificial intelligence, that allow these robots to behave more autonomously and adapt to new situations on the fly. And things are getting smaller and squishier. Miniaturization and soft robotics are leading to tiny, flexible robots that can squeeze into confined spaces or interact gently with their environment. Imagine origami-inspired robots that can fold themselves into different shapes for different types of movement, all while sensing their own bodies. Of course, enhanced sensory capabilities are key, with robots being equipped with a wider array of sensors for a much better understanding of their surroundings. And finally, we'll see more modular and reconfigurable robots, machines that can change their form or function to tackle different tasks or thrive in diverse environments. From exploring the deepest oceans and then climbing onto remote islands, to assisting in critical rescue operations and monitoring the health of our planet, amphibious robots are truly at the cutting edge. The journey to perfect these land and water explorers is ongoing, blending brilliant engineering with inspiration from the natural world. It's an exciting field to watch. That's all the time we have for today on G Fun Facts Online. We hope you're as amazed by these amphibious adventurers as we are. Join us next time for more incredible facts. Thanks for listening.